Hello, everyone. It's Julie Ray, and I'm here to talk about how to know whether to multiply or divide when you have a word problem in math. I'm going to share my screen with you so you can see what we're talking about. So, multiply or divide. How many tomatoes do we have altogether? We have 3 baskets of tomatoes. We have 4 tomatoes in each basket. And we're being asked to say how many in total. Well, that's a multiplication problem. 3 baskets times 4 tomatoes equals 12 tomatoes. Now, I always start with a simple problem to help me get my mind wrapped around what's going on. And I want to use this idea of having baskets. That makes a group. How many groups of tomatoes do we have? That's the group number is the number of baskets. So we have 3 baskets. And then how many individual items, what size is that group? That's the number of tomatoes in the basket. So we have 3 groups, 4 items in each group. We are either going to add 4 3 times or use multiplication to say 3 times 4 equals 12. Let's look at another simple concept to help us understand the next idea. So if I have this group of tomatoes, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tomatoes, and I want to put them in 3 baskets with an equal number in each basket, what am I actually saying? I'm going to take this total number of 12 and share it or divide it among these 3 baskets. So I want to divide this total group into 3 smaller groups. So how many will be in each basket? That equation comes out to be 12 tomatoes divided by 3 baskets equals 4 tomatoes in each basket. So again, the baskets are representing our groups, the number of groups we have, and then the 4 tomatoes is how many in each group. So the basket is how many groups. The 4 tomatoes is how many items in each group or the size of the group. Get the difference between these two. In multiplication, we have groups or parts that are the same size. You know how many groups or parts you have. Those are the baskets. You know how many baskets you have. And you know the size of each group or part, the number of tomatoes in the basket. And you're being asked to find the total number of items. So how does that differ from division then? In division, again, the groups or the parts that you're working with are the same size. However, you know the total. You're not being asked to find the total. You are given the total. So that is a piece of information that you have. How many altogether? You were asked to find either the number of groups or parts. You're either asked to say, well, how many baskets can I put this total in? Or you're asked to find the size of the groups or the parts. How many tomatoes can go in each basket? So it's either going to be I have 12 tomatoes. How many baskets do I need if I put 4 tomatoes in each basket? Or I have 3 baskets. How many tomatoes go in each basket? So the key concept here is that you know the total and you are dividing it or separating it into equal size groups and an equal number of groups. Let's look at a problem and see what we think it's asking us to do. Kiara must read a 348-page book in 3 weeks. She plans to read an equal number of pages each week. How many pages will she read each week? Let's see. She must read a 348-page book. That's giving me a total number of pages in the book. And she wants to read the book in 3 weeks. So I know the number of baskets, and I'm being asked to find an equal number of pages each week. So I'm being asked to find how many tomatoes am I going to put in each basket. Except in this case, instead of having a group of tomatoes, I have a total group of pages. I know how many baskets, 3. That's 3 weeks. The weeks are the same thing as the baskets. And I know that I'm going to read an equal number of pages each week. That's asking me how many tomatoes am I going to put in that basket? So how many pages will I read in each week? So the groups are the parts are the same size. So it's 3 weeks. It's not 1 week, 1 month, 1 year, 1 day. It's all weeks. I know that I'm also going to read an equal number of pages. So that's another way that these groups are the same size. I know that my total is 348. So I know the total. I know the number of groups, 3 weeks. And I'm asked to find the size of the groups. I'm going to make my full screen here. Okay, so I'm asked to find the size of the groups. I know the total. I know the number of groups. I'm asked to find the size of the groups. When I know the total and I'm trying to find the size of the group, I know that means division. I'm going to take this total number, divide it by the number of groups, and then I'll find the size of the group. In this case, I'm going to take the total number of pages, divide it by the number of weeks, and then I will be able to find how many pages in each group. So 348 pages divided by 3 weeks equals 116 pages each week. It's another situation. Terrell pays $189 per month on a car loan. How much does he spend in 12 months? Well, I'm talking about equal size groups because it's $189 per month. That isn't changing. Every month it's the same thing. And we're being asked to consider 12 months. So those are all equal. So I know the number of groups, 12 months. I know the size of each group, $189 in each group. And the question asks, how much does he spend in 12 months? That sounds like a total. So the groups and the parts are the same size. We checked that. We know how many groups, 12 months. We know the size of the groups, $189 in each one of our groups or months. And we're being asked to find the total number of items, in this case, the total number of dollars. So when we are being asked to find a total, our groups and parts are the same, and we know the number, then that's a multiplication problem. What would that multiplication problem be? $189 a month times 12 months. My total is $2,268. Shauna works 32 hours this week. She is paid $14 an hour. How much does she earn this week? It's like we have equal groups. We're talking about 32 hours. She's being paid $14 an hour. That stays the same. They're equal. How much does she earn this week? It's like they're asking me for a total. We know the number of groups, 32 hours. We know the size of the groups, $14. We're asked for the total multiplication problem. What does that look like? $32 hours, that's the number of groups, times $14 an hour, that's the size of each group. And my total is $448. So how much does Shauna earn this week? $448. Each month, Carlos pays $625 for rent. How much does he pay for rent in 2 years? Do I have equal groups? Yes. Each month, $625. That's not changing. How much does he pay for rent in 2 years? So they're asking me for a total amount. We know the number of groups. Notice here we have to do a little bit of thinking because it tells me that it's each month he pays $625, but we want to know the total for 2 years. So we have to think about that for a minute. Let's go on and see what else we know. We know the size of the groups. We know that each group has $625 in it. And we are asked to find the total number of items or how much he will pay all together. So let's go back and think about what that means. So we know the number of groups, we know the size of the groups, we're asked to find the total, a multiplication problem. But what are we going to be multiplying? Because he says each month Carlos pays $625. And we want to know how much in 2 years. Well, how many months are there in 1 year? 12 months. How many years do we have? 2. So we have to think about how many months in 2 years. 12 times 2 is 24. So we're going to be multiplying $625, which is the size of the group, by 24 months in 2 years. That's the number of groups. 625 times 24 equals 15,000. So he pays $15,000 in rent in 2 years. Last week, Best Buy had sales of $14,688 for new television sets, not just one. That should be plural, or new television sets. If each TV cost $458, including tax, how many TVs were sold? So what do we know here? We know that here is a total amount. They had sales of 14,688. We know that the number of dollars spent for each TV was 458. So we know the number of items in each group. And we're being asked to think, how many groups are there? Because we want to know how many TVs. So it's thinking of the TV as being the basket and how many dollars go in each basket. We need to know how many baskets were sold. We know the total amount of money. We know the size of the groups, $458 in each group. We're asked to find the number of groups, how many TVs. And this, whereas we think of TV as being one thing, when we're calling it the number of groups, think about it in terms of the TV being a basket and how many dollars are in each basket. So that's why it's being called a group. So if we know the total and we know either the size of the group or the number of the groups, then we know that's a division problem. And what would this division problem be? We're going to take our total, divide it by the number of dollars per TV, and that will give us the number of TVs that were sold. So $14,688 divided by 459, not 458, equals 32. If we divide it by 458, this would be 32 and a piece of a TV. So we would know somewhere we went wrong. And where I went wrong is right here. I made a typo. It should be 49. Okay. Marcus drove 177 miles on the first day of a 4-day trip. If he drives the same amount every day, how far will he travel? So I've been giving you some ways to think about what's going on in this problem. And the way we've been talking about it is that we have tomatoes in a basket and we know how many baskets, how many tomatoes, the total number of tomatoes, or we know the total number of tomatoes, we know the number of baskets, and we're trying to find out how many tomatoes. Let's just think about this in a just imagining what's going on. Get a picture in your brain. Marcus gets in his car and he drives 177 miles on the first day. And then he drives 177 miles on the next day. And then he does that again. And I'm just going to draw a little picture on my whiteboard to help me think about what's going on here. And why don't you take a minute and draw a picture on your paper or whiteboard, whatever you have available. Let's see if we come up with the same kind of thing. I'm going to stop sharing my screen and show you what I drew. Nope, I turned off my camera. Now I'm going to stop sharing my screen. So here's what I have. I started with, one day I went 177 miles, or Marcus did. The next day, Marcus went 177 miles. The next day, he went 177 miles. And the fourth day, he went 177 miles. So I can see that I have 4 groups, and each one has 177 miles. And I want to know, how far did he go all together? That is telling me it's a multiplication problem. That's another way of thinking about it, and something else you can do when you're trying to understand the problem and what it's asking you to do. Sometimes we have a tendency just to put the two numbers together in whatever way we comes to our mind first. And I'm encouraging you to either use an analogy that you like the tomatoes in a basket and how many baskets, or to draw yourself a picture which helps you see the same thing. So you need to kind of play with this and see what works best for you. I'm my strongest advice is for you to try some different things. And when you get to the one that where you say, oh, I see now, then that's the one that you should try first and see if that way makes sense to you when you have a problem. So in this one, we know the size of the groups. We know that there's 177 miles. We know the number of groups. So we know that there are 4 of these groups, 4 days. And we're being asked to find the total number of items. How far will he travel? So in total, from start to finish, how far will he go? We know if we're trying to find the total, we are going to be doing a multiplication problem. What multiplication problem are we doing? 177 miles times 4 days will give us the total distance that he traveled. So 177 times 4 equals 708 miles. So Marcus drove 708 miles on his 4-day trip. Maya plans to make 12 payments on new furniture. The total cost of the furniture is $1,152, $1,152. How much will her monthly payments be? So I'm going to encourage you to take a minute and draw out a picture that would tell you what's going on with this. And I'm going to do the same thing. Let's compare what our pictures look like. So I know I have pay $1,152. So this is a picture that I drew, which is interesting, I think, because we all think about time or calendar in a different way. And I drew a bar and put 12 blocks in it. 1, 2, 3, 4, 5, 6, 7, 8. There's 12 there. And I know that I have $1,152. And I'm trying to figure out how much goes into each month so that I know how much money I have to spend each month. That's what this problem looks like to me. Be interested to know what this problem looks like to you. But if we go back to our other analogy, we know the total number that we have. We know the number of groups that we have. And we're trying to find out how much goes in each group. So we know the total. We know the number of groups. It's 12 payments. And we're asked to find the size of the group. How many dollars is going into each of those 12 payments? So that would be a division problem. I'm taking $1,152 and I'm dividing it between 12 payments, 12 different baskets. And that will tell me how much my monthly payment, or Maya's monthly payments are. So 1,152 divided by 12 equals $96. So her monthly payments will be $96. So I know that sometimes word problems can be a little intimidating or off-putting, and that they're the things that you may like least, but really all of life is a word problem, and we're just trying to figure out how to approach it, what operation we need to use. So I hope this helped in giving you a couple of different ways to think about it, to think about whether we know the total or we're being asked to find the total, whether we're being asked to find the number of groups or the size of the groups. So if using the idea of putting different parts into baskets helps you, or whatever other picture you want to have in your mind, or if it helps you to draw it out and think carefully about what do I know and what am I being asked to find, then I think both of those strategies can be useful, and you just need to find which one works the best for you. But I think the more that we can do to really picture in our heads and understand what the problem is all about, the easier word problems become. So with a little bit of practice, I know you will get better and better and be an expert at approaching word problems. Thanks for listening. I hope it helped.